Alrighty, boys and girls, ladies and gents, children of all ages, here we go. It is Wednesday for you. It's actually Tuesday night for me, but I'm pretending, and I'm all decked out for Spirit Week this week in my jersey, repping my Chiefs and my Blues. But really, the Blues head is there just because I am in more desperate need of a haircut than I have ever been in my entire life. And no, I do not want any of you to give me a haircut, so don't even offer. How you guys doing? How you been? Here we go. We spent the last couple of days talking about radicals, talking about how we can simplify radicals. Now we're going to get into a whole bunch of other stuff involving radicals, namely adding and subtracting them today. So, quick throwback for you. When I see a problem that looks like this, how do I know which parts I can put together? I'm thinking of 3 words. I hope you said combine like terms, because that's what I'm thinking. Well, like terms are things that are the exact same variables and exponents. So we combine like terms when we are adding and subtracting variables. Remember, when you would combine like terms, you would always use the sign in front of the number. Never look behind the term for the sign you're going to use. You use the one that's in front. So I have a 3x minus 5x. That'd be negative 2x. Again, adding and subtracting. The thing I'm adding and subtracting doesn't change. It's not like multiplying where we had the rules and we added the exponents. If I got a plus 4y and a plus 7y, I put those two together. There's positive 11y. And that's it. That's the answer. They're not like terms. They can't be combined when we have addition and subtraction. When we talk about radicals, it's the exact same concept. You can only add and subtract when the radicals are the same. So I've got 2 root 3 plus 3 root 5 minus 4 root 3 minus 8 root 5. So the like terms are the root 3's. Again, use the sign in front. Positive 2 root 3 minus 4 root 3 is negative 2 root 3. Plus 3 root 5 minus 8 root 5 minus 5 root 5. That's the basic underlining behind today's idea. But just because I like making things a little bit more difficult, you take a look here. Are the radicals the same? No, of course they're not. It's an 18 and a 50, but I can't let you get away with something quite that easy. Hopefully you recognize the square root of 18 is going to simplify. It's a bigger number. Most bigger numbers break down. Not all of them. 30 doesn't, 130 doesn't, but most of your bigger numbers are going to break down. So here's what you got to do. You got to take a look. 18, break it down like we did yesterday. That's 9 times 2. 9 is 3 times 3. So this is 2, 3, 3. Pair of 3's gets out, and the 2 is left in. And like we talked about yesterday, if I take something out and there's a number out there, we just multiply them together. So I got the 2 3's on the outside, makes 9. The 2 on the inside is 2. Move on to the next term. Break down your 50. 5 and 10, 5 and 2. So 50 is 2, 5, and 5. The 5's get out. There's already a 5 out there, so we multiply those together. There's a 2 left in. So a problem that looked initially like it was not like terms is like terms. So I can go ahead and combine those. 9 minus 25 is negative 16 root 2. Final answer. We didn't have to do that here because 3 is a prime number, 5 is a prime number. It doesn't break down. If they're not prime numbers, you can look on your factor sheet to see if they're on there. Then they will break down somehow. If you break them down and you have like terms, add or subtract. Number 4. All right, I'm going to run through this one a little bit quicker because hopefully by now you recognize right here in this first term that's a very special number. The square root of 49 is 7. So this, I'm not even going to do the factor tree because I am smart like you guys and I recognize a perfect square. So I know that's just 6 times 7. That's just 42. I go to the second one. I know 64 is a perfect square. So that is 5 times 8, 40. I'm not even going to put in work there because I know, like you guys, I recognize those perfect squares. I want you to get there. I want you to say, hey, that's a perfect square. I know it's a whole number answer and move on. Don't spend time doing something you don't need to be doing. I get along here to 24. 24 is not a perfect square. 25 is, 24 is not. So I go back and I go in and I break it down. 24. 6 times 4. 2 times 3. 2 times 2. So I got 3 2s and a 3. Only pairs of numbers get out. The 2 and the 3 are left in. So the pair of 2s comes out. There's a 3 out there. So that makes 6 root. I got 2 things left inside the radical. So that leaves 6 root 6. Next one, 54. Not a perfect square. Break it down. 9 times 6. 3 times 3. 2 times 3. So I got 2 and 3. 3's inside my radical. Pairs of numbers break out. So on the outside I got the 3 and the 7. On the inside I got the 2 and the 3. Multiply those two together and I've got 21 root 6. Now I find my like terms and I combine them. 40 minus 42. Whole numbers, 2. 6 root 6 minus 21 root 6. Those are like terms. Final answer. So, add and subtract, combine like terms. Same ideas when we deal with variables. We've been doing this for a long time. Same concept. We're just going to add some of the stuff from the last 2 days. And we spent 2 days simplifying these radicals. So you should be pretty good. The assessments that came back yesterday were much better than Monday's. I got confidence you guys got this now. Simplify your radicals. Add or subtract what's left over. I want you to get to where you recognize these perfect squares and you don't have to break them down anymore. You just know that's a whole number answer. Stay safe. Take care. I'm going to try and set up a face-to-face for this afternoon. And I'll put the information in Classroom. Until then, see you.